Hi students. Today we have to discuss about the decimal expansion of rational numbers. Rational numbers are all numbers which can be expressed in the form p by q, where p and q are integers and q not equal to 0. 7 by 8, 1 by 3, 0.2121, 1 by 2, minus 2 by 3 are some examples of rational numbers. Decimal expansion of rational numbers are divided into two: terminating rational number and non-terminating rational number. The expansion of terminating rational number has an end. For example, 7 by 8 equal to 0.875. Here, the decimal expansion of 7 by 8 ends at 5. The decimal expansion of non-terminating rational number has no end. Non-terminating rational number is again divided into two: recurring non-terminating rational number and non-recurring non-terminating rational number, otherwise called as irrational numbers. The decimal expansion of recurring non-terminating rational number has repeating digits. For example, 10 by 3 equal to 3.333, etc. The decimal expansion of non-recurring non-terminating rational number has no repeating digits. Now we have to convert a rational number to decimal form. The first example is 36 by 100. Here dividend is 36 and divisor is 100. 36 can't be divided by 100. So put a decimal point to add 0 in the dividend. Now 360 divided by 100 is 3. 3 into 100 is 300. Now we have to subtract 360 minus 300 is 60. We can't divide 60 by 100. So we add 0. 600 divided by 100 is 6. 6 into 100 is 600. 600 minus 600 is 0. Therefore, 36 by 100 equal to 0.36. Therefore, the decimal expansion of rational number 36 by 100 is 0.36. Now, the second example is 1 by 11. Here, 1 is the dividend and 11 is the divisor. 1 can be divided by 11. So, put a decimal point in the quotient to add 0 in the dividend. Again, we can't divide 10 by 11. So, we add again a 0 to the quotient to add 0 in the dividend. Then 100 divided by 11 is 9. 9 into 11 is 99. 100 minus 99 is 1. Again, we add a 0. 10 can't be divided by 11. So, we add 0 to the quotient to add a 0 in the new dividend. Then 100 by 11 is 9. That is, there are 9 11s in 100. 9 into 11 is again 99. 100 minus 99 is 1. Add 0. We can't divide 10 by 11. So, add 0 to the quotient to add 0 to the new dividend. 100 divided by 11 is again 9. 9 into 11 is 99. Again, 100 minus 99 is 1, and so on. Therefore, 1 by 11 is calculated as 0.090909, etc. And 1 by 11 is a non-terminating recurring rational number. Now, we have to convert terminating decimal expansion to rational numbers. Let x be a rational number whose decimal expansion terminates. Then x can be expressed in the form p by q, where p and q are co-prime, and the prime factorization of q is of the form 2 raised to n times 5 raised to m, where n, m are non-negative integers. Now, we have to study how to convert terminating decimal expansion to rational numbers. First example is 3.142678. Here, after the decimal point, there are 6 digits. So, we multiply 3.142678 with 1 lakh. That is 3.142678 into 1, and there are 6 zeros. 1, 2, 3, 4, 5, 6 equal to 3142678. It is written as 3142678 divided by 1 lakh equal to 3.142678. Now we have to convert 1 lakh. 3142678 divided by 10 raised to, here there are 6 zeros, so 10 raised to 6 equal to 3142678 divided by 10 raised to 6 is written as 2 raised to 6 into 5 raised to 6. Since we know that 10 raised to n equal to 2 raised to n into 5 raised to n. Now we have to convert recurring non-terminating decimal expansion to rational numbers. Example 1, 1.272727 etc. It is written as 1.27 bar. Here 2 digit is repeating. Let x equal to 1.272727 etc. Here there are 2 digit is repeating, that is 2 and 7. So we multiply x by 100, that is 100x equal to 100 into 1.272727 etc. That is 100x equal to 127.2727 etc. Now we have to subtract 1.272727 from 127.272727. That is 127.2727 etc. minus 1.272727 etc. equal to 126. Here 127.2727 etc. is 100x. That is 100x minus 1.272727 etc. is x equal to 126. 100x minus 1x is 99x equal to 126. Therefore, x equal to 126 divided by 99. It is reduced as 14 by 11. Now, we have to study about two theorems. Theorem 1. Let x equal to p by q be a rational number such that the prime factorization of q is of the form 2 raised to n into 5 raised to m, where n, m are non-negative integers, then x has a decimal expansion which terminate. For example, 23 divided by 2 raised to 3 into 5 raised to 2. Here, the denominator is in the form of 2 raised to n into 5 raised to m. Therefore, this is a terminating rational number. Next example is 13 divided by 3125. We can write 3125 as 5 raised to 5 into 2 raised to 0. And the denominator is right in the form of 2 raised to n into 5 raised to m. Therefore, this is a terminating rational number. Now, the theorem 2 states that let x equal to p by q, where p and q are co-primes, be a rational number such that the prime factorization of q is not of the form 2 raised to n into 5 raised to m, where n, m are non-negative integers, then x has a decimal expansion which is non-terminating, repeating or recurring. Example for theorem 2. 129 divided by 2 square into 5 raised to 7 into 7 raised to 5. Here, the denominator are not in the form 2 raised to n into 5 raised to m. Therefore, this is a non-terminating recurring rational number. Another example is 29 divided by 343. The denominator 343 cannot be divided by 2 or 5. So, 2 and 5 are not the prime factorization of 343. Therefore, we cannot write 343 in the form 2 raised to n into 5 raised to m. Therefore, this is a non-terminating recurring rational number.